Third episode of Spring in Winter, where we discuss testing our Spring applications like pros. It will be a full hands-on session where we'll write some unit tests, integration tests, and discuss when should you apply one or another. Well, don't forget that you also have a live chat there, so you can ask me questions in the live chat if you wish. And of course, I expect you that you can also follow me on Twitter if you'd like. I'm the Laurențiu Spilcă, the author of Spring Security in Action and Spring Quickly. And today again, we're going to discuss in the third episode of Spring in Winter how to write properly our unit and integration tests in a Spring application, and we'll do it in a full hands-on session. So with that being said, let me share you my screen and we'll start by discussing an application, and this is a very small application I did just before our stream to prove the way we can implement our unit tests, and we will use it as our application to be tested. It's a very small application, as I said. You only have two controllers. I will start by describing you the class design and the architecture of the application. As some of you have already noticed, you see it's actually a very simple Spring Boot example. I'm using the latest version of Java, which is Java 15 at the moment, but that's less important. And in the pom.xml file, you can check out that I'm also using the latest version of Spring Boot. And what you'll see is that it's an application working with a couple of tables in a MySQL database. So we have a standard linear class design controller service repository, and that's what looks like a lot of applications today, a lot of backend applications today in the real world out there. You know, we have some REST endpoints exposed by a backend, and they are consumed by some front end or by some mobile application. And one of the tasks is, of course, to test this. These endpoints and the functionality of such kind of applications, and that's basically what we're gonna do now. So you see my test folder here is completely empty. I have no class. We're not going to work all the unit and integration tests for the app because you're gonna be bored if we just repeat a lot of things. Anyway, developers usually get bored of writing unit tests, which makes unit tests difficult because unit and integration tests in general, they are easy to implement, but they are very boring. And I understand you if you consider them boring. I do also consider them myself, but they are necessary. And they are an important part in your application. That's why even in my latest book, Spring Security in Action, I dedicated an entire chapter about writing integration tests with Spring Security functionalities for testing your authentication and authorization. So if you'll ever check Spring Security in Action, you will find out chapter 20. We won't discuss now about Spring Security because we'll have later another episode on Spring Security. We'll actually have 4 more episodes on Spring Security in January. But if you'd like to know more details about testing your Spring Security implementations, then you'll see that's another story, and that's why I dedicated. It's a complex story, and that's why I dedicated a full chapter in Spring Security in Action for that. Okay, enough talk. So again, it's just a normal simple web application. I'm connecting using JDBC, so I'm not using Hibernate or JPA here. It's not that important in general what's our repository using, because we're anyway going to mock it. And if you are not aware what a mock is, I will explain what a mock is in very, very soon. So stay with me here. I'm using MySQL, and that's why I have the MySQL connector driver, JDBC driver, but we are not going to use it very much because we're going to focus on the unit and integration tests today. And you see, of course, very important, we have the dependency for Spring Boot starter test, and I'll be going to use JUnit 5. And again, we're going to use mocks in some of our tests, for which I needed the Mockito dependencies you see here. So with that being said, let's go a little bit through the endpoints of our application to see what we're going to test, and then go straight into implementing the 3 main, mostly used kinds of tests in Spring applications, and I will drive you through how to write such tests and explain you the characteristics of each of these kinds of tests. And then I will also tell you which are the best practices, when should you use a specific kind of test, and the fact that you shouldn't duplicate the testing logic as well, that's important. You'll see that depending on what you test in your application, the way you implement your unit or integration test is important. And I very often find developers miss these details, and they end with either working more than necessary, either implementing tests that take a longer time in their pipeline. Of course, maybe taking a longer time is not that important, but in the end, imagine that if you run the pipeline multiple times and you implement pipelines for each of your feature branch, then of course you don't want to wait for your pipeline 20 minutes for a specific feature you implemented in one of your microservices, rather than waiting a couple of minutes. So it might be relevant in terms of not always want to take a break every time you run your pipeline to wait for a specific feature to be deployed, and that's where implementing the unit test to be also efficient is important as well. And you see that depending on how you write your unit or integration tests, you might make them more efficient or less efficient in terms of your pipeline running. So we're going to discuss some things that are really relevant today for your real world implementations and the tests you write in your applications in production apps. And that's why I prepared already the application, and I'm not writing it as usually. Usually you see me writing applications on the spot, but now, because I want you to focus specifically only on the unit tests, I wrote the application previously. So you see it's very simple. It has two controller classes. They are simple REST controllers. The destination controller is used, it is defining an endpoint that is accessible via HTTP post, and you can use it to store a specific destination. I like to remember those times where we weren't living in a pandemic world, and I was able to travel for winter holidays, so that's why I'm nostalgic about that. So you see my application today is about not only holidays but destinations where you can travel. Unfortunately, today and this year I won't be able to travel a lot, but I like to remember those times. So let's remember those times by writing this application and testing these applications that's related to our holidays and specific destinations for our holidays. So yeah, with this endpoint, which is basically directly linked to the /destinations path you see as a prefix with request mapping on my controller, you will be able to add a destination. And you see, when I add a destination, then I will of course call a service to create. That's the business logic behind. I will show you the service immediately. But then when I get a saved destination, I put it on the body of my response, and then I send also a status of HTTP 201 created 201, if I remember correctly. Hope I'm not mistaken. I'm usually mistaking 201 with 204, but yeah, we'll see immediately. It's irrelevant. And that's when we create this destination, we add it into the database. Oh, sorry, this is only a mapper. I will tell you immediately why. When we create the destination, this is the method inside my service. You see, this is basically only a service class marked with transactional, because the use case I want it to be on one transaction. And that's the transaction will automatically be opened by Spring when the create method is called, and will be closed by Spring at the end of the method. If of course the transaction will be committed if of course we don't have any exception, any runtime exception. That's by default in Spring. And here you see we call the create. So the full logic of this method is we are checking if the destination with that name already exists in our database. If it already exists, then we throw a duplicate destination exception. So we throw an exception in case we already have the destination And in case we don't have it, then we simply create and return the destination. The destination is created in one of our two tables in a database. We have a couple of tables. One of the tables is storing the destinations, and the other one is storing the holidays, and we consider a one-to-many relationship between holiday and destination. So you might have one destination for multiple holidays. And you can see also the create method. Again, I'm showing it. I show you the create method and the repository, but it's not that relevant. Just for you to see it, it's only inserting. I'm using JDBC template, as I've told you from the beginning. I'm not using JPA here. I'm just using JDBC template, and this is only an insert into the database. But again, as you will see, because we are not focusing now on the repository itself, it's not really relevant what and how the repository is implemented. You just can consider that's doing the right thing, and I promise you it's actually doing the right thing, so it's not a problem with that. But we will focus on the test. So you have this, all the methods sending queries that are either retrieving data from the database, like checking a destination by name or checking a destination by ID, and inserting the destinations, as well as a second repository I have for the holidays, which is basically doing merely the same thing, inserting a holiday, in this case, in the database. So they are simple repositories using JDBC template to store the records into one of the two tables I have. So it's just, again, our application is a controller service repository application that's we are going to test actually. So let's go into the tests. First of all, I like to create here the package that's called plain tests. I'm creating a package that's called plain tests because the first test we're going to create are classical unit tests. I'm going to start with a class that's very simple here. We have a notification service, and this is a dummy service. You see, it doesn't have any dependencies. I have especially created it like this to have no dependencies. You can just imagine, of course, in a real world scenario, this notification service would be an object that's sending a notification to the user when they require a visa for a specific destination they want to go. So you see, it's only a method here returning a true or a false. It takes the destination as a parameter, and in case the country is one of those countries known by our application to require a visa, then the return value of the method will be true. And you can imagine here I'm only printing something in the console. In a real world example, you just imagine that's going to be sending the notification to your application. It can be a push notification to a mobile app, or it can be a notification sent through a WebSocket in a web application. We don't really care. I would like to start with this service, and I'd like to start with it because it actually has no dependencies. So we just start with what a unit test is, and we'll implement our unit tests, a couple of unit tests for this method to get a little bit warmed with this technology. And then we'll go a little bit further into a class that has also dependencies, and we discuss what happens when a specific method has dependencies, and that's where you're going to learn how to use mocks, and we're going to use one of the most used technologies for this today, which is called Mockito. So the notification service, let me actually create a class here that I will call notification service tests. So in this notification service tests, what I'm going to do is just declaring a private notification service. Actually, I think the best would be to put it in the test app directly. What do we test for the very beginning? So when we have a unit test, what you want to do is check basically all the relevant flows of a specific method. For example, you might want to check that in case your method takes a destination that's null as a parameter, it behaves correctly by throwing a runtime exception. Or you might want to check that if the destination is not null but is not part of the list, the visa required will be false. And of course, the third may be important in this case. Flow would be that if the destination requires a visa, then the method returns true. And in sometimes with also, like when we have a depend here, we would probably have a dependency in a real world example. So in this case, you'd probably want to test as well that a dependency is called, but that's something that I will show you in the next example. So I'm starting with this very simple one now. So let's say we say public void, and our test is test sending a null destination, and we need to annotate our test method with @test. And then what I usually recommend everyone is, especially if they are using JUnit 5, use the display name annotation to give a specific description, because if you read this method name, you don't necessarily understand quite well, or it might be more difficult to understand what the method is for. You don't, in a real world scenario, you don't necessarily know all the scenarios. So now maybe it's easier because I've just explained the scenario, so it's easier to read the name and understand what it is. But imagine in a real world scenario, you might not necessarily know it up front, so it's very comfortable to actually have a more detailed description. So I usually recommend developers to use the display name annotation to give a specific, more detailed description for the unit test, because if you don't use the display name annotation, then the name of the method will be the one taken. And I've seen this anti-pattern of developers writing huge name for their tests just because they try to put everything in the name of the method. But trust me, understanding a name of the method that's 300 characters long is not necessarily easier. So writing just a sentence here, or maybe a couple of sentences in the display name, describing nicely what happens and why is this test for, is much better. And this is one of the first pro tips you learn from this presentation of today. Use the display name where possible so that you correctly describe the scenario tested by your unit test. Of course, today expect I'm not using display name for the next methods, just because I want to avoid spending time in this presentation unnecessarily. But in a real world, in a production app, I would actually use display name for all my tests. So here I can say test that the notification service method throws an exception when the destination is sent as null. Anyway, it might be rephrased to be a little bit nicer, but I just wanted to prove you what this means. And now, of course, when you run your test, which by the way, you run it either by clicking here on these arrows, which will run all the tests in the class, either by running a specific test. Sometimes we want to run for all the project by right-clicking on the name of the project and run all the tests of the project. I will just run them from here now, and you will see that my test is doing nothing, I know, but I want to show you that display name works and that you will basically see it here. And if you have, see, this is the display name here, which you can nicely read the sentence that describes our scenario. So when a test will be failing, it's much easier to simply read the longer description in the display name. And that's going to be also in a report if you are configuring some kind of a plugin for your Maven or Gradle project to put them in a report, like a Jacoco report. You will see this description as well there. And again, when you see the report, it's again much easier to simply read and see which were the tests that were failing. Now, again, what I'm going to do here is just a simple plain, how I call it, unit test that's not referring to any dependency. So my notification service, new notification service, will call the method send notification for Visa, and I'm testing, of course, what happens when I send a null. So when I send null, what I do expect is that the method throws, so I'm using the assert throws method here, which I have to import it, and it has two parameters. One of them is the exception that is thrown, and the second is, of course, an executor that calls the method to check. By the way, you see me here, I'm throwing runtime exception, which is not necessarily, I would say, good practice in a real world scenario. Mind that sometimes I do hurry when I'm writing examples and I'm not necessarily implementing all the things in the right way. Like in this case here, I'm directly throwing a runtime exception, but remember that in a real world scenario, you should always have a custom exception that's nicely describing that situation that you consider exceptional. So don't use runtime exception as I've done here in your case. But anyway, use a runtime exception, but it will be a custom exception of your own. And in my case here, you can see that now when I will be running this, I should see that the check remains on green, because I expect that send notification for Visa will indeed throw an exception, a runtime exception, when the destination is null. And you see that indeed my test it is correct, which means that the method behaves as I expected. And that's the first scenario. So what we did by now, we actually tested what's by here when I'm actually throwing the exception. Now let's test what happens if a visa is not required. So in my case, you see that a visa is required if the country is one of those in this static list. I made it here for our example: USA, Cuba, and Thailand. And let's say we want to have a case in which a visa is not required. So in this case, I will simply create another method that I call test sending notification for visa not required. And again, it doesn't really matter how you name your method now, because as I discussed a little bit earlier, you will always, now I'm not doing that anymore because I want to spare the time, but you will always in your real world examples use the display name annotation, so you make sure you have a nice description here. So keep that in mind always. And now look what I'm doing. I'm gonna call again the method, but this time I'm not expecting an exception. What I will be actually doing, I will be sending a destination D, new destination, and I make sure that the country is not one of those that you have seen in the first list. So I'm going to just make sure that I'm on the case where a visa is not required. So this case here where in the method, in my method flow, it doesn't go through this if here. So that's basically it. So what country should we place here? Says France. So we have France. We don't need for France a visa, and that's when I'm going to say result, and I want to check that the result in this case is false. So I use an assert. When I'm writing unit tests, mind which is the assert false in this case, which is the flow. The flow is basically have some prerequisites, call the method, validate that the behavior is the one expected. So that's what you do every time. These are the main 3 steps you every time have to think about when you write a test, either unit or integration test. So you have some prerequisites. In my case, the destination is a specific destination. Then you call the method you want to test, and then you assert the result. For example, in this case, you want to make sure that the result is false for France. That's because in our applications logic for this country, we don't require a visa. So again, running my both tests now, we should see that both of them are green, and that's testing two of three important flows in our application. See, of course, you see the difference. That's even better here. You see the difference between having the display name and not having the display name. So you see how ugly the name of the method is here. And if you see this on a report, on a unit test report, and you try to read it and understand what scenario is this method covering, it's of course, and you have to agree with me, much more difficult than reading a nice sentence like this one here where we use the display names. That's why I'm recommending you using the display name whenever is possible, all the time actually. And of course then we have the case in which we expect the visa for visa required. So in this case we say USA, and I expect it to be true for this, and I assert that a visa is required when the country is one of those in our list. So that's the third test, and then these are simple plain unit tests, and you see the logic for the unit test. You have a method, it has some specific responsibility, you know its responsibility, and you find out the cases that are relevant for your application. Mind that in a real world scenario there might be more than the cases you need to test. Sometimes you have branches that are not that relevant to be tested. I heard that and I'm still hearing this in sometimes that our tests should always cover everything, should always cover 100% branches of our application. And my advice for you is not take a target of the percentage you want to cover. So it's still okay if your coverage is not 100%, as long as you know that for every method you took all the important scenarios, all the important cases, the majority of them, those that are if it happens that they don't work, it's critical. That's at least what you need to take and test for your application. So you don't necessarily have to go and test each and every exception. Like what happens if I would be going to test here the holiday repository? Am I going to test all the possible exceptions my method create would throw from the, I don't know, this parameter creator, or from this generated key holder, or from the JDBC template itself? Should I actually test everything? That's of course not only questions that you ask yourself for a repository. You ask yourself these questions in any kind of implementations you have, because you will find out that sometimes it's irrelevant to test absolutely all the cases. But it's very relevant to always find out which are the important ones that are critical for the functionality of your application, and test all those cases. Because then what's the benefit of it? When you will go back and you have to implement a new feature, you will have to change code and use code that already exists as well. So when adding new code and changing code that already exists to solve a bug or implement a feature, you want to make sure that if you affected some critical functionality of your application, something that already exists in your application, you want to make sure that you find it out in the development and you don't ship it to your customer. So the tests will automatically, when running them, and especially because you will put them, you will configure them to be automatically called on your pipeline, they will notify you if you broke something in the existing functionality of the application. And then, being that you are notified in the development stage, you will be able to solve the issue and always deliver the new features together with code, with the features which stay in place the way they should in your app. That means they are still working and you don't break something that already exists in your application. That's very important. Okay, but that was the simplest scenario, a class where we don't have dependencies. And many of you would tell me in this case, and I have my students always tell me in the class now, okay, but in real world scenarios, come on, man, classes do have dependencies. It's very rarely in a real world application that you don't have a dependency at all, is it? So yes, you do have dependencies. So let's see what happens when you want to write a unit test, but you have the dependencies, and that's the next thing we'd like to do. And what I'm going to do, I'm going to take one of our services, say the destination service. And this destination service, you see, it has the create method we've seen at the beginning of the video that's creating a new destination if the destination doesn't already exist. And what I want to do is make sure that I unit test properly this application. But in this case, as you can see, unlike the previous example with the notification service, we have a dependency, and you see the dependency here, the destination repository. When I call the create method, my create method first of all checks by calling this method of the repository if the destination exists or not, and throws an exception if the destination already exists. Otherwise, we call a second method to create the destination if it doesn't exist. So that's what we basically want to test in the end. These two flows, the fact that the create method throws an exception and doesn't add a new destination in case it already exists, and that in case the destination doesn't exist, it creates the method. But we don't want to go inside the dependency itself, because remember, a unit test is called a unit test because it only tests only one unit of logic in your application. So it only has to test code in this method. It cannot go deeper into the repository and use the repository. So what we are going to do, how can we avoid the call of the method going into its dependency? Well, we can use what we name a mock object. A mock object is a fake object that you control and that you inject into your object you test to make sure you don't delegate further to a real repository in our case, and to somehow from the test control the way the test goes. So for example, you can just configure your mock object to return an empty optional here, and then you know if it returns an empty optional here, you know that this create method should be next called. That's one thing you can do with a mock. You can tell the mock what to do when a specific method is called. So you can just control the get by name. You can say in this test, get by name should return an empty optional. And that way you go on a specific flow of your method. In this case, if this method returns an empty optional, you know precisely that this will be skipped, the exception won't be thrown, and then you will end up by executing the create method. And the second important thing you need to do, and you can do with mocks, is checking a specific method has been executed, because in this case, what we are going to test precisely in this case, we're going to test if the create method has been called, and when you have a return value, you also want to assert the fact that the value that has been returned is the right one that you expected to have been returned. So let's try to actually let's implement it to be more clear what we want to do here. And in my package here, I create a new class, and I'm calling it destination service, and allow me calling it destination service plain tests, even though it's not really a proper name. But in our case, in the same project, we'll have more kinds of tests, and I want to name the classes such that later you remember them more easier. So what am I doing here? Basically, I will be doing more or less the same thing I'm doing in this class. I'm going to write test methods, and in my case, as you've seen, I have two branches. I have to test one of them, what happens if the destination exists. The second one, what happens is if the destination doesn't exist. So that's what I'm going to test. But the difference is that I have unlike this case here in the notifications, now I have also dependency. So I have a dependency which is the destination repository. So now I really need to use a mock. And what do you do when we have a dependency and you want to fake a specific dependency? So you want to use mocks. You need to extend your unit engine capabilities with this with this mock capability, with this mocking capability that will allow you define precisely how and which is the branch you want to test in your application. So that's where we use the extend with Mockito extension, because that's what I said at the beginning we are going to use. Mockito is one of the most known, maybe the most used technology dependency for creating mock objects. You are going to see this very often, so that's why I chose it. And let's take it and try to use it in our application here. Let's actually try to see how can we use Mockito to write our tests. So our first test, the first test we'd like to write is test that an exception is thrown when the destination exists. And don't forget that the name of the method is irrelevant, and you don't necessarily have to write a long name of the method if you use the display name annotation. That's why I always tell developers, do use the display name annotation. Is very, very relevant in case of when in a real application, when you try to read a real report where you might have hundreds of unit tests. It's really relevant. It spares you a lot of time reading in a nice sentence the description of the scenario. So I'm not doing this now because I want to spare time, but you should always make sure that you use a display name in your real world scenarios. And now look at what I'm going to do. I'm going to define, so I'm going to use here a specific injection to take the object I want to mock, and then I will inject this mock into the object I want to test. So which is my dependency? Which is the object that I want to fake? Which is the object I want to fake and control? Is the repository. The repository, which is this repository here, the destination repository. You see, I can simply take it like this, and then I will define it as a mock by using the mock annotation from Mockito. So the mock annotation simply creates, with the Mockito extension, will intercept the mock annotation and will create a mock for me. And then what I'm going to do, I need of course the object that I want to test. The object I want to test in my case is the destination service. So what I'm going to do is say destination service, and then inject mocks, which means create me a real destination service object and inside it inject all the mocks it needs that I have previously defined. Well, the order is not important actually in terms of order in which you put them here. I sometimes get this question from my students, is the order important? No, but it's usually better, or at least I see it better when I first define the mocks and then I define the real object and I say inject those mocks. And the flow goes the same way. You will have to call the method, but you have some assumptions first. So then say you have a destination D is new destination, an object that you want to test. Let's first see what is the equals definition here. We don't have an equals definition, so in this case, if you don't have an equals definition, that actually means that you are going to use the reference of the method, because we are using the way the object class defines the equals. Sometimes that's not really good, so I do recommend you define equals and hash code. Let's assume here in our case we rely on the IDs and only on the IDs, and that's in a real world application. Of course, you know precisely how to implement your equals and hash code. This is only a test and we don't really care, but it's better to have it like in a real world example, have a way to compare the two instances. And then I won't fill all the others. I just create my destination D here. So these are the prerequisites. Then I call the method, and then I have to see what happens. But how can I now, at the third point of writing my unit test, decide what should happen if I don't know what will my destination repository actually do? So I can't. But being that I have mocked this destination repository object, it means that I can control it. So look what I'm going to do here in my test. I'm going to say when the method from my repository that's called getByName with any kind of parameter provided, so we don't care which is the parameter, and of course I have to also import the when, then return, and then I'm in the case where I'm testing that the destination already exists, so I'm going to say optional off and say is this destination here, just to avoid using some other object. So this destination already exists. What do we expect if the destination already exists? If the optional is not empty, it doesn't even matter what's inside, because when the destination is not empty, then we know that in the logic of our application, if the destination is not empty, then an exception will be thrown. This duplicate destination exception. So what we are going to do, we are going to assert throws, which is assert that our application, our method throws the duplicate destination exception when we call the service with a destination that already exists. And that's how this is part of our prerequisites. So we have the destination, but we also configure our mock to return a non-empty optional when the getByName method is called. And then when you call the create, you know that if this method returns an optional that's not empty, it will basically enter the if present here and it will throw the duplicate destination exception. So that's why here in the test, I assert that indeed when calling this method, if the destination already exists, then I see the duplicate destination exception class. And by making use of the mock, what you see is the way I avoided to go in the real object, in the real dependency object, which really makes my test a unit test, because otherwise if I would have gone into the repository, then it meant that I would have used the repository and even the database further, and I don't want that. I really just want to test the logic of my service class, which is the logic of my use case. In the service classes we have use cases, and that's where we have the logic that creates it's the business logic that gives value to our application that we sell to our customer. And that's where you really need to make sure somehow you get to test it. And that's where you want to make sure, of course, that if you do changes further in the future, you won't affect things that already exist. Then, of course, you have the other test where you say test that a destination is created when it doesn't exist. And then it's pretty easy to change this, because now the only thing you need to do is to make this return empty, an optional empty. So now if you configure your mock such that when the getByName method returns an empty optional, you know that the logic will not enter the if present anymore, because now the optional that has been returned by this is empty. And what you want to make sure is that create is called and returns a specific object for that destination. So what we are going to do is, instead of the assert throws, we just call the method and we take the result, which is the destination we get as a result. And we want to make sure, again, that the destination repository, when it's called, it returns something we know that we can test. So remember, this is still a mock object, which means that we can control what create is doing. So I'm going to do the same thing I've done here and say, when create for D, which is my destination I give as a parameter here, is called, then return, and I can use D as well. I can return the same destination, and then I call the method and I assert that indeed this result that has been returned by the method I test in the service returns the same thing that the destination repository actually returned. So I do an assert equals expected result is the given result. And let's call again our two tests and make sure that the unit tests work properly. These kinds of tests, with or without mocking a dependency, is what we call plain tests, and they are the fastest tests you can implement. When you write a Spring application, my recommendation for you is, whenever you have some kind of logic in a service or in a manager or in any kind of other component you define, say, name it whatever you'd like it to name, you'd like to test your logic this way when it's only your logic you want to test. Then you want to use the fastest way for your test to go, and the fastest way is basically avoid interacting with Spring. Did any of you observe that in my tests here I'm actually using no Spring annotation, no Spring integration? So I'm doing this on purpose, and I'm doing this, and I'm using some plain unit tests with Mockito for my dependencies where is needed, because I want to avoid integrating with the framework when I only test my logic. So mind that this is the fastest way to go, and that's the best way to go when what you want is not testing something that means integrating with a specific Spring capability. Even though you have a Spring app, it doesn't mean you need to create Spring tests, because Spring tests are not simple unit tests. They are basically integration tests. Why are they called integration tests? Because they don't only test the logic, the simple logic, a unit of logic of our application. They basically, besides that, test also the integration with the framework itself. And you do that, for example, when you want to test the integration with a specific capability, like you want to test the dependency injection. If you want to test the dependency injection in your app, then you won't use simple plain text as I've done here. You will have to use Spring Boot tests, in my case being a Spring Boot app, or simply Spring tests in case of a Spring Vanilla application. But in that case, we are going a little bit further into not only testing the logic, what we are doing here, but also testing the integration with some specific framework capability, some specific capability of our application framework. That's why all the tests that you will find in chapter 20 of the Spring Security in Action, they are named integration tests, because they are tests that they are testing basically the integration of your logic with Spring Security and the way you have configured your authentication and authorization with Spring Security. Let's do ourselves some integration tests with Spring this time as well, and see the difference and see what happens. First of all, how we write them, and then of course discuss on the difference between the plain and the integration, Spring integration tests. So I'm going to create another package. I'm going to call it Spring integration, and you will see that I'm going to create a class. And let's also say this is destination, because we don't want to focus again on something else. We'll still test the destination, but we'll write the test a little bit differently so that now it also tests the integration with the Spring inversion of control container. I'll call it destination service Spring integration tests. And in order to do that, I'm going to add a Spring Boot test annotation. That's one big difference. Let's compare these classes. Here I have added an extension for Mockito. But in this case, I'm not only adding an extension, I'm actually letting Spring Boot manage my tests in behind so that I can do directly auto wiring, like from the Spring context into the test. And in my case, if I still want, and I still want in this case to test the destination service, I'm just saying destination service. I'm placing an auto wired above it, and I'm going to use it as is. And then you will ask, okay, what we're going to do with our dependencies, because if I'm going to write the same thing, and I'm going to write basically the same thing, the test isn't different, or not a lot. You will say, okay, but we have the destination repository, which is a dependency. What can we do about that? Well, we do the same thing that we've done previously. We mock it. We create that fake object we can control in order to tell our method which is the branch we'd like to test. We test how the method behaves depending on how the dependency behaves. Just that, when you were using plain unit tests with mocks, you were using the mock and the inject mocks, which allow the Mockito extension go and manage the fields. In this case, you use auto-wired, which means you actually allow Spring itself manage the test. So that when I declare here private destination repository, sorry for that, destination repository, I'm going to use the mock bean annotation. And mock bean, and I see this confusion sometimes in class when my students ask, what is the difference between mock and mock bean? And by the way, I still like, it's just my preference, but I still like to put them in this order. Well, the difference is that mockbean, first of all, if you take the look in the import itself, you will see that mockbean is part of Spring Framework boot test capability. While in case of the mock, you see it's part of Mockito directly. That tells us something. It tells us that this is a dependency managed by Spring that doesn't only create a mock. It creates a mock, but it also makes sure that it puts the mock in the context. It's like what you were doing when on your class you were using a stereotype annotation, or in your context, in your application context, you were creating an @bean annotated method. You don't have to do that anymore. Just place the mock bean annotation and Spring will do for you precisely what you expect it to do. Will create a mock and will make it a bean in the context. That will automatically be injected now because you used here auto-wired and destination service is a component itself. And you don't see the auto-wired here because I'm doing a dependency injection through the constructor. But here in the parameter of the constructor, where Spring injects the dependency, Spring will basically inject here my mock object now. Which one? This one, the one I have defined with mockbean. And that's how now, when I say the same thing, I'm controlling my mock here the same way I did previously. It will basically work the same, and you can actually reuse the same logic, Mind that this is not this. I'm not saying here that you should do both these kinds of tests in the same application, because I'm rewriting logic the same way. You see here, you don't want that. You don't want in your application rewrite logic. So in this case, in between plain and Spring integration tests, you want to decide which is the kind of test you use, because it doesn't make any sense to define both of them into the same application. You have to take a decision whether you'd like or not to test the integration with Spring itself. And then if you'd like to integrate with your application framework and also test the auto wiring, then this is the way to go. But when I will run this, you will basically see that in this case, what Spring will do is rising the context. The inversion of control container is now created. The Spring context is going to be up and running. And that might be a problem because it means it's slower. You see how much slower? See that? So now it's booting the Spring context. And then only was able to run my tests after the Spring context was up and running. While in the case of the first test that I called plain tests, if you run this one, you will see that no Spring context is created. The tests are directly executed. So that's the difference between a Spring integration, that's where you integrate with the application framework as well, versus using a plain unit test. The plain unit test will always be faster. But sometimes you'd like not only testing the logic, but also integrating with the application framework. So that's where it matters. If you want to integrate with the application framework, because, for example, as I described here in chapter 20, you want to test your authorization and authentication configurations, then you need to do that. You need to integrate with the framework, and then your tests need to be a little bit more than just plain unit tests. But if you only want to test the logic of your application, then you of course don't need to integrate with the framework, and what you need then is not a Spring Boot test, is not a integration test with your application as well. It's only a test for the logic itself using some plain Mockito extension in case you need to define mock objects, which is of course very often encountered in real world examples. And these are the first two kinds of tests any Spring developer should be aware of. And when you start an application, you should always take into consideration what kind of test should you actually write. Now let's go into the third test and the last one we want to discuss, the controller integration test. Let's create a new package. Create a new package. Controllers integration. And that's a kind of test which you usually see, and I generally recommend for any kind of application that exposes REST APIs. And again, I don't have to say once more that having REST APIs with Spring Boot applications is very often encountered out there. How do we test the functionality that's accessed through a REST endpoint? That's a good question. That's an excellent question we should always ask. What do we want to do? Do we want to go to a plain unit test? Do we want to write a Spring integration test? But in the case of the REST API, I often recommend the controller integration tests. And that's very simple, a very simple kind of test, easy to write, with a dependency that's called mockMVC. mockMVC is a capability that allows you act as the client of a specific REST service. Your unit test acts like the client of a specific endpoint, and then you can test it and the logic behind it if you wish. But by directly calling the controller like your client does, which client can be any kind of application calling your REST endpoint, a mobile app, a front end written with React or Angular, a desktop application, another service. But why do I like so much writing controller integration tests instead of, say, simply Spring integration tests or unit tests? Is because they allow me decouple a little bit more from the implementation and act upon the contract itself, because the controller, you can always see the endpoint itself as a contract. Is the contract the client and the server have on which they agree when they share a specific functionality that the client needs to call and the server provides. And sometimes we don't care so much to test all the tiny details of our implementation in the service. We only care, as in the case of a controller and the REST endpoint implementation, we not only, but mostly care of some cases that are important for the client. Say, what status of the message is the client receiving in a specific case? What's the body of the message? Should the body contain a specific information, data? Should the body have a specific form, a specific shape? These kinds of things we care. Because in the end, when we implement a REST endpoint in a server, we do care more about how the client sees the endpoint rather than how the implementation is done in behind. So why not writing the tests, the unit tests as well? They're actually integration tests. The integration tests as well, such that they don't test directly the logic, but that they test the logic the way the client does it through the controller by calling the endpoint itself. That's how it goes. And let's actually write a third test now for the destination. I will call it the destination service controller integration tests. And what I'm going to do here, Spring Boot test, and I'm doing an auto configure mock MVC, which will, in case of Spring Boot, which you see, it's very nice, and that's that convention over configuration approach. It allows you very easily auto configure a lot of the things by convention. That's why we love Spring Boot. That's why Spring Boot is one of the favorites of any Spring developer. The auto configure mock MVC basically configures behind everything you need to know for this capability of testing your application by calling directly the controller. And then look what I'm going to do. Now I'm not injecting directly any object from my application, and I'm not testing directly any of the objects I have in my application. I'm not testing the controller, I'm not testing the service. You'll say, why? What's that? You are not testing the controller, then why did you actually call your class destination service controller integration tests? Well, I'm not testing the controller, meaning I'm not testing directly the object in the Spring context. I'm not going to auto-wire my destination controller and apply tests directly on the object as I've done in the Spring integration. That was what we discussed a little bit earlier in the Spring integration. What I'm going to do now is directly inject this mock MVC object. If you wonder why I have it in the context already, is because of this annotation here that instructs Spring Boot to configure this object in the context, add it to the context and configure it properly for me being directly able to write the tests. And then what I'm going to do is, of course, directly I'm going to indirectly call the controller and then test what happens here in the controller. And if I wish, I can basically mock the destination service. And in some cases, I can even allow it go further, not here further, here further in the create, and test even the flow in the service. And that way I might avoid, if I wish, in case of APIs, but that only works in case of REST APIs, test my functionality in the service by calling the controller directly and see what happens. Let's try to do that. So What am I going actually to mock here? I'm not going to mock the map, or I'm not going to mock the service, but I'm going to avoid going to the database because it's only a test, and at most I'd like to go into the business logic and test the logic here, which is the two cases you have already seen, whether I have or not a destination, I will add it or not. And now what I can do is basically I can use a mock bean. I can still use a mock bean. So I'm saying destination repository. And this way I configure the destination repository as a mock bean in my context. And then I'm writing the test destination created if not exist, or whatever you like to name your test. Also, don't forget my advice from the very beginning. Always use the display name annotation to give a nice description to your test. Is something always a pro developer knows and does. I'm now skipping that only to save time because it's already, you see, I'm 1 hour past the time for the presentation, but I'm sure nobody will kick me out. So I still want to go to end my presentation with everything I planned. Yeah, what am I going to do here? Basically the same thing again. So it's mostly the same thing I'm doing here. I will make sure that the destination doesn't exist. That means my repository will still return an empty optional. But you see, instead of calling the method directly, I'm going to say mock MVC perform, and that's performing an HTTP request. What kind of HTTP request do I need here? Well, I have to see what kind of method do I use. I need a post request, isn't it? So I need a post request on the destinations. And then I will go into this endpoint here, if I'm going to post into destinations. So I say perform post into destinations. Will import this method. I actually would like to check that the method I've imported is correctly, because I know my IntelliJ sometimes screws up with my imports. Yes, it's correct. And that's basically also throwing an exception, so I'm going to throw it to propagate it out of the method. And then I will say and expect. So you see, this is very similar in terms of logic of the test with what we've done here. So we have some prerequisites, we call the method, and then we say what we expect. The assert is what we expect. So I expect something to happen. Same I do here. I say I have some prerequisites, I call the endpoint like a client, like one of my clients, and then I say, and I expect something, and then of course in a real world example, you would basically write here all the things that you expect, like the body should look in a specific form. The status should be one that you expect. I'll only check actually here. Allow me only check here the status. Say status is created. If I remember correctly, is created. I had the impression I should already have it here. Isn't it created? First of all, let me check first of all if it's created, just not to. So created, yes. So I had the impression that this is created here. Strange. So it doesn't have a method for the created. Or maybe didn't I actually import the correct status? Oh, it looks like it's the correct status. Anyway, is and created, if I remember correctly, created is 201 or something like that. Because I'm not sure now why is that not displaying me the screen. I had the impression it's there. Did I miss it? Somebody tells me in the chat is there. Let me look. It's too late for me now. You see, guys, it's 11 p.m. for me, so I have an excuse. Oh, it's created. It was just the first one, just between my nose, just below my nose. Sorry. Thank you very much, Max. Great spotted it. Yeah, I had the impression that I should see it there, but I don't know how I missed it. Probably too late for me. And of course, you might spot here that something is missing as well, because I went directly to and expect. Well, you actually, besides calling the destinations, what else do you need to send is the body itself, because we expect a body. Headers in case you need them. In my case, it's only a body. This destination request body, that's a simple class. So see how is the request actually, how does it need to look like, is it needs to have a name, a country, and the destination type, which is an enumeration. So name, country, destination type. So in my case, I should write something post content, and content is basically the response itself. You can, because I'm using Java 15, I can use this nice operator, which is actually new from Java 15 available, and you can use it to spare a lot of pluses and quotes when writing a string, and directly write here my JSON, which should look something like this. Say name of the destination, New York, country and that will be USA, and then what was the last one? Destination type. So destination type, which is city. I've seen there in the destination type one of them was city, so it should be okay. And then I should also say that content type, it expects content type, media type, application JSON, because that's what we are sending here. Is it's a JSON formatted string, and that's basically it. Let's see if it's working. So if I didn't again do something wrong, then we should be able to see a green light. And sometimes maybe you are asking, okay, yeah, I've written this like a string block, and that's because I have a very small response body. What should I do if I don't have a response body? Then we have the possibility to use an object mapper. Well, I see something didn't go well here for some reason. Null pointer exception. Oh, save destination is null, because we didn't say what create is doing, is it? So our mistake now is that, well, I have here two methods, and in case of a mock, if you don't say what a method is doing, it will automatically return null, for example. So that's what in my case. A question. Why not use the object for the input? Because the object is not supported, if I remember correctly, in mock MVC. I might be wrong, but I don't think it simply works with just sending here the object itself like D. We can try it if you'd like, but when I remember the last time, I was actually always using an object mapper to transform first the object into a JSON, but I will try both of them. Let me just correct my mistake here. So my mistake was that I have to also tell my mock what should do in case of a create, otherwise it will return a null. So I'm just going to do something like this, and this should solve my problem. Now I'm telling this is D, this will be the response basically. Of course, I can also check on the response. Again, in a real world scenario, I'm not only checking the status, I'm also checking the body. Sometimes I need to check that it looks in a specific way. We will spare some time by not doing it now because it's irrelevant. You go to the point, I guess. And then now it's working, it's fine. And now your question was, why am I not using the directory, for example? Why can't I actually use directly an object like this? And again, from what I remember, going with the object directly is not possible in the input. I'm not sure if something like this has been implemented lately, but with content at least, it's not possible to directly go with the destination object like this. So say this is my input, then I need to have say a name, New York, the country, you say destination type, city. And what I'm actually doing, or what I've been doing in projects, because of course, you might wonder, well, what am I doing in case I have a huge object? I can't actually literally put the string in there, is it? So what I'm doing, I'm using an object, a simple object mapper, and I'm doing something like this. I just say object mapper new object mapper. Then say mapper write it was, let me remember, it was write to object or something like that, with write value as a string, sorry, write value as a string, that was it. So I'm taking it like this is my request body, and then I'm doing it like this. Yeah, and of course this can be just placed somewhere in the Spring context. You don't have to put it in each and every method. Would use the request object when then use a mapper for JSON. Yes, that's what I wanted to say, exactly like this. That's what I wanted to say. And of course I'm taking this out such that I don't have to repeat this code in all the tests. I'm just putting it either in the Spring context, either putting it somewhere in an util class, and I don't repeat it, and I'm just using the write value as a string method, and that should be actually working the same here without needing me to write the whole object as a string, because in a real world example usually it doesn't have only 3 attributes, it might have 30 attributes, and when it has 30 attributes and you have 10 tests, then you would have a 1000 line test class, and you don't want that, and it's irrelevant. So it's much easier just to use an object mapper and transform your object into a string like this, and you see it's basically working the same way. And of course that doesn't mean that we discussed today all about unit tests. The unit and integration test is a huge object. Manning has also some other books about it. Even there you might skip things because it's a very very big subject. It's a big epic into working with unit and integration tests. You can do containers test, you can do contract based tests, you can do a lot of things. And there are plenty of ways to test your application, but my purpose for today was to give you the 3 most important and most encountered ways of writing unit and integration tests in a Spring application. And remember, plain tests, the fastest, when you want to only test your logic, the logic in a service, the logic in a manager, the logic in some of your components, and you don't want to integrate because you don't need to integrate with your framework, then write simple plain texts that look like this. You can use an extension for your mocks, and then you don't need to rely on the application framework at all, because relying on the application framework, in our case Spring, means that you need to spin up the inversion of control containers, so spin up the Spring context, and that takes time. And then you allow also Spring do some tips and do some tricks there, and control by controlling through specific aspects your code, the tests will become slower. So if you don't need to integrate with Spring to test a specific functionality like the dependency injection or a kind of an aspect you'd like to test, then it's irrelevant to write Spring integration tests, and you'll probably, and my advice is you go with plain tests, because they are much faster and they will be enough for you. If they are not enough for you because you want to test some specific functionality, like testing your security configurations, like testing some kind of aspect you have configured, like testing your dependency injection, then you can't go with a plain test, but your savior will be a Spring integration test. That's very similar. You write the test the same way using Mockito, but instead of having simple objects that are not part of any context, you now really have objects that are part of the play of the Spring context. Even the mock objects themselves become beans in the context, and then you can use them from there. You can auto-wire them. They work the same as normal object, and you work with them in the tests. That's the second step. And remember, again, my advice for REST APIs is usually much better to act as your client, and through mock MVC not only test the logic in behind by making sure that you test all the relevant branches, but test them like your client calls the REST endpoint you created. Call them through the endpoint directly, not by testing your object in the context, but directly acting as your client on a specific path and doing the call and checking what happens, what's in the response on the HTTP, or if an exception is thrown, and so on and so forth. Because in case of a REST API, the relevant and much more relevant is what the client receives in the end, and that's what you want to test. And a last advice on this side from myself: don't repeat code in your tests. If you decided to test your REST APIs like this, then don't add another series of tests like this and like this to have the same logic repeated. It doesn't bring you any benefit. I've seen this anti-pattern in some projects. Developers were actually losing twice the time to write and test the same logic in the controller and in through a Spring integration test or a plain test. Remember, avoid repeating logic. Even if they are tests, they are still have to comply to clean coding rules. So that keep it short and simple, and you ain't gonna need it, and don't repeat yourself principles. They apply here as well. Try to fulfill and respect all the principles that you do for your normal code into the unit tests as well, and avoid repeating logic. I often see this, and I don't understand why people decide to work more when they can actually work less. And that's basically my today's presentation. Thank you so much for being here with me in Spring in Winter series. The Spring in Winter series will continue with 4 more episodes in January, where we discuss topics related to Spring security, which is even a subject that I could say I love even more, because yeah, you see, I've written a book about it, so that proves I really like Spring security, and we'll discuss again some nice things about Spring security in those 4 episodes. But up to that point, I wish you happy holidays and have a good rest during this couple of weeks with maybe with your family and your friends. And avoid any viruses if possible. Stay safe. Thank you very much, and have a great time for learning. Happy holidays, everyone.